So we have two problems here dealing with tangents and secants. Each circle has a tangent and a secant extending from the same point outside of the circle. One, we are solving for segment lengths, and the other, we're solving for the angle created between the tangent and the secant. So let's first look at the number 3 here that's dealing with the length, or the relationship between the length of the tangent and the secant. So the formula that we have says that this length of the tangent, the length of the tangent squared, so this length AB squared, is equal to the product of the initial segment of the segment from A, let's try that again, from A to C, that distance times the length of the whole from A to E. So if we just plug these numbers into this formula, we see that we are solving for AB, so we don't know what AB is, so we'll say x for AB squared is equal to AC is 3 times CE. CE is 5, so if this A to C is 3 and C to E is 5, then the length of AE from here to here, the length of the whole, is going to be 3 plus 5, or 8. So we'll write times 3 plus 5, or 8. And then it's just quick computation here. X squared is equal to 3 times 8, which is equal to x squared is equal to 24. And then, of course, if we want to do the inverse operation of squaring something, that is to take the square root. So we would take the square root of both sides, square root of x squared and the square root of 24. And because x represents the length of AB, then we only are interested in the positive number. So we say x is equal to the positive square root of 24. And when we are, we can use our prime factorization here in order to simplify this. Well, this is the same thing as 4 times 6, or the square root of 4 times the square root of 6, which is going to be 2 root 6 simplified. So x is equal to 2 root 6, or the length of AB is 2 root 6. So if we come over here then and look at now, instead of this length here, we're interested in solving for the angle in between. So this formula says the angle between the tangent and the secant, which is angle A, has a relationship with this far arc, which is going to be B to E, and the relationship of the closer arc subtended there, which is B to C. And it says the far arc here minus the close arc divided by 2 is equal to my angle. And the information that they give us is that the arc CE, which is here, so let's do this in blue, arc CE is 170 degrees, and then it says the arc of BC is 60 degrees. So we still have two missing pieces here. We have what we're solving for, angle A, but we also don't know this BE yet, which we can just use simple arithmetic to find that out, because we know the number of degrees in a circle is 360. Well, if we subtract what we already know, which is the 170 plus 60, that will give us the remaining BE, the arc of BE. So when we add those together, we get 360 minus 230, leaving us with 130 is equal to this arc. So the measure of arc BE is 130. So now we can plug these values in. Angle A is equal to the far arc, or BE, which is 130, minus the close arc, which is BC, which is 60, all divided by 2. And a quick simplification here is 130 minus 60 is 70, divided by 2 is equal to 35 degrees. And the angle A equals 35 degrees is our final answer.